Well, hello everyone, and welcome back to Adrian's Digital Basement. On the last couple of videos, I've worked on this Franklin Ace 1200, reviving it both by fixing the power supply, then fixing the keyboard, and then fixing the disk drives. The machine has been working absolutely fantastic since I did that repair in the last video. I've put maybe 6 or 7 hours on this thing since then, and it's performed absolutely flawlessly. The disk drives are now working perfectly. At the end of the last video, I mentioned that there were some expansion cards that originally came with this computer that I wanted to test out. So in this video, I'm going to do that. But I also have some other cards I want to talk about and test as well. Some stuff I bought on eBay, they're all Apple II cards. And to do this testing, I'm actually going to use an Apple II Plus just because it's a bit smaller, won't take up so much space on the bench. This thing is actually rather large. And well, this thing doesn't have the RAM expansion, and a couple of the cards I want to test add extra RAM to this, while the Franklin Ace 1200 and the 1000 already have built-in RAM. We'll talk more about that after the break. So without further ado, let's get right to it. Let's start with the 80 column cards. So a little background, the Apple II and the Apple II Plus did not have built-in 80 column text capability. They only had 40 column. Apple later introduced the Apple IIe with built-in 80 column support right on the motherboard, and all subsequent Apple IIs after that had the 80 column support built right in. Since the original Apple II was such an expandable machine with those 8 expansion slots, it didn't take very long for a company to release an 80 column add-in card that went into the original Apple II. Now, the 80 column card that I have right here is the one that was inside that Franklin Ace 1200 because it is modeled after the Apple II Plus, which doesn't have the built-in 80 column support. So it was through an add-in board. But what I went ahead and did is I searched on eBay and actually found one of the original Apple II 80 column cards, not made by Apple, it's made by a third-party company, and it's actually inside this bag here. Now, as you can see, this is still wrapped up from when it was shipped to me, and I haven't taken a look at it even in person, and I don't know if it works, but here it is. Now, if we take a look at the architecture of this 80 column card and pretty much all the 80 column cards that came after this, it's pretty simple. There's a ROM chip, there's a 6845 CRT controller, there's some video memory here for the actual frame buffer, and then there's some logic chips. And you can see here there's a composite output jack. This is where you would connect up a monitor to display your 80 column text. Now, flipping the board over, we can see the company marked it here with their brand name. It's the M&R Enterprises Sup'R'Terminal. And this was released, as far as I'm aware, in 1979. Now, this card, as I mentioned, was, as far as I'm aware, the very first card that was released for the Apple II. But very soon after, another company named Videx released their own 80 column card, which, from my understanding, is essentially a clone of this card. It's not like a copy when it comes to the layout, but it works exactly the same way. Now, I don't actually have one of these original Videx cards. It doesn't really matter because all the clones that came after it basically work exactly the same way. But here's a picture of it. We have a CRT controller. We have a couple ROM chips. One is for fonts, 7:9 fonts, and then this is the actual program ROM, some logic chips, and then we have the video memory. Now, the actual name of this Videx card is the Videoterm 80 column display, and as far as I'm aware, it came out in 1981, 2 years after this Sup'R'Terminal card. And well, actually looking at the manual, 1980 is the first date in here. And notice that Videx actually is based in Corvallis, Oregon, which is just not too far south of Portland. Now, taking a look at the Sup'R'Terminal manual kind of explains a little bit more about these cards, these 80 column cards. You'll notice in this section here, it's talking about how the Sup'R'Terminal's display output is independent of the original Apple II video that's on the motherboard. You'll notice it says you route the video signal to your monitor via a separate video cable, and you'll need a physical switch to switch your monitor between the output of the Apple II on the motherboard and the 80 column display. So they actually talk here not about using a switch, but using 2 separate screens at the same time. And that's actually totally possible with any of these original Apple II 80 column cards. It's not possible on the IIe or any of the later machines. These cards implement their own display buffer that is totally separate, meaning you can run a dual monitor setup on your Apple II, one 40 column, one 80 column, and access them independently. Normally something like AppleSoft Basic will only use one or the other, but while you're using the 80 column card, you can still write to the 40 column screen by just putting information directly into the 40 column screen memory, the buffer area, So you can display text on both. Now in the back of the manual for the Videx Videoterm, they actually have the full schematics for the card. So they weren't really trying to hide the fact of, well, how it was designed, hence the fact that so many clones were made of it. But they also introduced something that the Sup'R'Terminal didn't have, and it's this Softswitch capability. It's an extra little module, which I've talked about in a previous video, so I'll link to that down below in the description. There's a replica of it now, but this separate little module plugs onto the motherboard and takes a couple signals off the motherboard and allows the system to switch between the 40-column display and the 80-column display automatically. Now in part 1, I alluded to the fact that the Franklin Ace 80-column card has this auto-switching capability built right in. And that's what these two cables are right here that are connected to the card. One of them plugs into the auxiliary video connector on the Apple II motherboard, well, or on the Franklin motherboard, and this picks up the actual 40-column display and the graphics display and routes it into the 80-column card. And then this other wire here has a single pin connector, and on the Franklin Ace, this is connected to a pin that is not there on the regular Apple II and allows this card to sense whether you're using the graphics modes, so the card will automatically switch back to 40-column display, which is also where the graphics come out of. Going back to the schematics, this side of the schematics here is where it connects to the motherboard. It's picking up 5 volts and ground, and then 2 different signals that are routed through a couple transistors. Let's refer to the excellent book, The Apple II Circuit Description, to see exactly what the 2 signals are that it picks up off the motherboard. Here is the IC F14 that the Videx Softswitch circuit board plugs into on the Apple II and the Apple II Plus motherboard. And you'll notice the outputs here, there it is, pin 4, text mode. Now, the true name of this is actually text/GR, which is graphics, and that line toggles depending on whether a graphics mode is enabled or text mode is enabled on the Apple II. That is pin 4 right here on the Softswitch schematic. But you notice it also has pin 9. What's that all about? Well, if we go back and we look at pin 9 here on F14, this is actually one of the enunciators. There are 4 enunciators on the Apple II joystick port that are basically controlled from F14. These are outputs that you can toggle from the 6502 assembly language side of the Apple II. You can toggle these 4 lines and you can pick them up off the joystick port, which happens to be a little dip socket on the motherboard. And you can use them for your own devices. Like you could have it turn on a circuit that activates a light or turns on a motor or a fan or things like that. Now you might be asking, here's pin 9, what does enunciator 0 on the Softswitch module have to do with the 80-column switching? Well, my hunch is this. The ROM here on the original Videx card, when you enter 80-column mode by typing PR number 3 in BASIC, it actually toggles that enunciator, which will cause the Softswitch module to turn on the 80-column display. Because normally you're going to be looking at power up at the 40-column display on your Apple II, and only when you initialize the 80-column card do you want to switch over to that display. And you see these connections right here that are on that little Softswitch board. And I know we're looking at the schematic and not the actual board, but believe me, it's just a little PCB with some parts on it. The Apple Video In connection here is the same as this connector right here on the Franklin card, which plugs into the auxiliary video output on the motherboard. So it takes the video input from the motherboard and it uses these 2 transistors to switch between the 80-column input from the Videx Videoterm, or any clone video board for that matter, and the internal 40-column display off the motherboard, which is this connector. And then through this little 5-pin connector on the Softswitch board, that is the switched video output, which is what goes to your monitor. Now, going back to these 2 cards, the reason why I've been talking about all that is because I'm pretty sure what's happened on this card is that Franklin has just taken the Softswitch module and integrated it directly into this board. They got rid of the need to have that separate little board plugged into the motherboard, and they did that by having this cable here, which picks up the 40-column video from the motherboard, and this wire right here, which picks up pin 4, that text/GR signal off that chip F14. Now you might be asking, what about this pin 9? Why isn't this used anymore on the Franklin card? Well, I'm not 100% sure how this works, but my hypothesis is because the original Videx Videoterm board was never designed in the first place to have the video switch, it doesn't have an output on the actual 80-column card that could send to a little switch module to say, hey, I'm in 80-column mode, switch to me. So it relies on that enunciator signal to do that. But this card, obviously, the card itself could easily be programmed through the ROM on here, one of these is the ROM, I'm not sure which, to toggle something on this board that takes the place of that enunciator 0 on the motherboard. If we look here around the video output connector, there are some transistors, which is almost certainly used to do this switching functionality that the Softswitch module does. And instead of needing to pick up enunciator 0 off the motherboard, that signal is just picked up off one of these logic chips right on this board, which allows you to save an extra wire. Now, for testing this Franklin board in the Apple II Plus, it doesn't have the single pin on the motherboard for me to connect up to that text/GR signal. But all I need to do is stick a little pin into here and then clip onto that leg number 4 on F14 on the motherboard, and it will do the same function. As I had mentioned, I'm pretty sure that this ROMs on here emulate the exact functionality of the Videx Videoterm card. So all of the control codes and other functions that card uses to manipulate text, move the cursor around, and stuff like that, are all replicated exactly the same in this board. And let's go back to the photo of the Videx Videoterm, and I just want to do a little bit of a closer comparison. So these 4 chips here, these are 2114 SRAMs. Pretty common. These are the same thing as the color RAM on the Commodore 64. These are 1024 by 4-bit SRAM chips. So you take 2 of them together and you equal 1 kilobyte of memory. So with 4 of these chips here, we have a total of 2 kilobytes of memory, which happens to be enough for a full display of 80 by 24 column text. Going back to the cards I have on my bench here, we can see there's a little bit of a difference. The Franklin card doesn't appear to have any of those 2114 SRAM chips at all. All we see really are logic chips, ROM chips, and the CRT controller. But actually, it looks like right here is a larger SRAM chip. This appears to be, well, it says it's a 4016, which I think is a 16 kilobit by 8 SRAM chip. Let's take a look at that. And yes, it looks exactly like that, 2K by 8, which is 16 kilobits. So this one larger IC takes the place of those 4 SRAM chips. But otherwise, I think the design of this is pretty much the same, where it's got these 2 ROM chips, one there and one there. One is going to be the program code ROM, and one is going to be the font ROM. It's going to hold all the fonts that are possible to display on the screen. Now, the Videx Videoterm board actually has the capability of an extra ROM socket here, and I think the reason for that is because these ROM chips are smaller, older ROM chips that cannot hold multiple character sets. So this one is the normal standard text mode, not inverse text, and usually the second socket here is to place another character ROM that gives you either additional character sets, like perhaps Japanese characters or other languages, or inverse text of this ROM. Now, the Franklin board doesn't have space for an extra ROM chip, so I'm pretty sure what they did is they took both of those character ROMs, the inverse one and the normal text, and they combined it into one double size EEPROM here. And actually, I can see on the board here, it says that these are 2516s, which are the same thing as a 2716, so 16 kilobits as well. These are both 2 kilobytes in size each. And I might be wrong about this actually, because going over to the ROM dumps for the Videx Videoterm, each of these files is 2K in size. So that means if you have the normal text plus like the inverse text, you would need a 4K EEPROM to hold both of those sets. Well, we're going to have to test how this works exactly. Maybe this does inverted text without needing a separate ROM, but just takes the regular ROM and inverts the bits as it goes through the shift register out to the video display. Now, going back to the Sup'R'Terminal board, notice it actually has 6 of these 2114 SRAMs, which gives it an additional 1 kilobyte of memory over the 2K that's found on the Franklin card or the Videx Videoterm. I wonder what that's used for. My hunch is that it's quite possible that this board has software redefinable character set, and it's possible that the main program ROM here actually contains the character set already, and maybe when you initialize this card, it just copies that part of it into the SRAM here, and then that's used to display the text on the screen. But if you want to modify it while the system is running, you can modify the font that's loaded into the SRAM. This is just a hypothesis. I have no idea if this is actually true. Let's check the manual. Now in the Sup'R'Terminal manual, I'm suddenly worried that I'm not going to be able to get this working, because take a look at this. Parts required for installation. You need the Sup'R'Terminal board itself, an adapter plug-in board. Well, the problem is I didn't get this board with any kind of adapter plug-in board here, and let's try to see if we can figure out what exactly that is. It's telling us we need to remove IC C2 from the motherboard, and yeah, it looks like you plug this into the motherboard, and then you insert the original IC you removed back into this board, and it says we have to connect the cable leading from the adapter board to the 4-pin connector on the Sup'R'Terminal board, which happens to be right here, right above the composite video output from the board. Now we have a picture here of the adapter board going into the motherboard. Okay, pretty standard stuff. and then connecting up to the Sup'R'Terminal board. Looks like there are a couple adjustments on the Sup'R'Terminal board to adjust the video signal strength and the signal balance, also known as image sharpness. Anyhow, let's keep reading here on the Sup'R'Terminal. So it says here that a cold start is performed the first time, is initialized after power up, and the character set is transferred from the EEPROM to the character storage RAM. So it's exactly like I thought, that extra SRAM on there is used for a software to redefinable character, something they did away with on the Videx Videoterm, probably in effort to reduce the cost of the board over this. SRAM was very expensive, especially at the time these boards were made, so saving 2 extra chips probably had a somewhat significant impact on the cost of this board. And I suppose Videx, when they made the Videoterm, decided that it just wasn't worth having the redefinable characters, and they could add that optional second EEPROM socket, which you could use if you wanted to have an extended character set. Now, these are the escape commands that these cards use to manipulate text and move the cursor around versus the normal 40-column mode on the Apple II. And here they are. This is for the Sup'R'Terminal: cursor back, cursor up, down, clear to end of line, clear to the end of screen, cursor up, clear screen. Some of these escape codes work in 40-column mode. I think the up, down, left, right, this I, J, M, and K, but all the rest of these do not work. So these are specific to the 80-column card. And you can also alter the case if you don't have the shift mod by using the Control A character. And this is while you're in 80-column mode, Control A will switch between uppercase and lowercase. Now, when I said the Videx card was a clone of the Sup'R'Terminal, it's not really a clone electrically, but I think they replicated the entire command set and the whole programming interface of the 80-column board when they made the Videx card, so that all the software that was written originally or patched to work on the Sup'R'Terminal should work on the Videoterm. And here's an example of that. I'm in the Videoterm manual, and there it is: advanced cursor, backspace, move down line, up line, clear screen. Yeah, like I think they really did replicate everything because they didn't want to reinvent the wheel when it came to software compatibility. And that means that all the software that was made later that was really targeting the Videx Videoterm should work on the Sup'R'Terminal. At least that's my hope. Now, of course, the Sup'R'Terminal supports that redefinable character set, and I don't know if it includes a character editor on the floppy disk that came with this thing, but it gives you instructions here on how to load that RAM character set. You B-load it right into the memory. And there's even a whole section in here about how to make your own fonts as well, and you can do it from BASIC, so that's pretty cool. Now, what I am looking for is information on what that little adapter board for the Sup'R'Terminal does, because I don't have it and I want to know if this board is going to work. Now, what I was hoping is that this manual had some schematics in it, and unfortunately that is not the case. There's a lot of disassembled code here, I think, what's in the ROM, so that's nice. But without schematics, we're not really getting a lot of information here. So I think what I gotta do is I'm gonna go look up what that IC on the motherboard is, C2. Let's look at what signals are even on that IC. C2 is used for RAM refresh. There's row address select, column address select, and there is also a signal that does eventually go to the video address generator. And I'm wondering if this is some kind of a timing thing that it uses to synchronize the Sup'R'Terminal board to the Apple II's internal, I don't know, signal timing. And it's something that it can't get over the expansion slot. So enough talking, let's try to test these boards out, and let's see if the Sup'R'Terminal board works without anything connected up to this pin header here. All right, here is the Apple II. All right, so this Apple II Plus, and I'm sorry if I confuse Apple II and Apple II Plus, because the Apple II and the II Plus are identical machines. Essentially, the II Plus just had an auto start ROM built in from the factory, which means instead of booting to machine language monitor, it just boots into BASIC. Other than that, basically all the same. And if we look up in the corner, this one has a date, which is a bit hard to see. There it is, 1981, third week. That's when this particular Apple II was made, or II Plus. Now, I like this particular Apple II Plus because the keyboard here is an Alps keyboard, so it feels really good to type on, and it also entirely works. I have another Apple II Plus that is older. I think it's from 1979 sometime, and it's got the Datanetics keyboard, which is the same one that the original Apple II has, which I made a video on my channel about an Apple II I was working on for a friend, and that keyboard was a basket case. And in a similar fashion, the Apple II Plus machine I have with the Datanetics keyboard is also a mess, where a bunch of the keys don't work very well, not to mention it doesn't feel very nice to type on, while this thing feels incredible to type on. It's such a nice, wonderful Alps SKCC keyboard. Anyhow, it's a bone stock machine. It has AppleSoft Basic on here, but otherwise just 48K, and that's it. Now it does actually have the original Super mod here, which is made by that same company that made the Sup'R'Terminal board, the 80 column board that we've been talking about. This little thing here is an RF modulator for the Apple II. Anyhow, let's actually turn this machine on so you can see it working in normal 40 column mode. Here is the RetroTink, and it's bright, but it should dim down, but there it is. It's all looking good. Now, of course, because we don't have the 80 column card in here, PR number 3 doesn't actually work. Now, so let's stick in one of these cards. Let's start with the Sup'R'Terminal card. PR number 3, slot number 3, the 0, 1, 2, 3. This is kind of the normal slot that this card would go into. It doesn't have to go into this card, but I suppose in the manual, when I was looking at the Sup'R'Terminal card, it talked about the fact that you should stick it in slot 3. That was kind of the slot they just determined that made the most sense. And because of that decision, every board ever since pretty much always goes into slot 3. And software always looks for an 80 column card in slot 3. And the Apple IIe and the IIc also emulates an 80 column card on slot 3. All right, so if I turn this computer on, it should be working fine. Good, the card's not causing the computer to not work. Let's do PR number 3. Now I'm expecting, without plugging the video output into this, that we're not gonna get anything. That's normal, but let's push Control G. Okay, we're still getting a beep. It kind of implies that this card may well be working. I'm gonna take the video cable off the back here, and I'm gonna snake this around here and try to connect this up to the board. It's a little tough because this thing is close to the keyboard. Let's turn this back on. And of course, we're not seeing a video signal because this card's not initialized yet. PR number 3, we are getting black screen. The computer that's responding, I type in garbage there, gave us a beep, but yet there's no video. Now these video knobs here do supposedly control the video output level, and you can see there, it is doing that. And let's turn this other one, and that's not doing anything either. So I have a feeling this card is just not possible to work without those extra signals coming in from the motherboard. So we'll turn the computer off. So I guess the question is, I mean, it's possible that this card has a fault, but I have a feeling there's no point to even try to troubleshoot this card until I understand exactly how that little adapter board works. I need to do some looking around to see if I can find any schematics for this. And I just had a little bit of brain fade, obviously, because we have the Sup'R'Terminal directory here with all of the stuff in here, and maybe there's photos of this. So there's an ad and front and back. Let's just take a look at these pictures. Oh, look, there's the little board. What exactly are we talking about here? 74LS00, so that's just an inverter buffer. I think this here is not meant to plug anything into. You don't plug something into this. This is a socket that has long legs, and that's what plugs into the motherboard. And you take the IC out of C2 and you stick it in right here. So it must be taking 1 or 2 or 3 or 4, I don't know how many signals off of C2 and potentially inverting them and then sending them over these wires here. Now let's go back here and take a look at the back. Maybe they took a picture of the back of that little adapter board. Oh, they did! They did indeed. Looks like this white wire here goes over here to that pin, and it looks like the black wire goes over here to that pin. I also wonder that this socket right here, on the other side of the board, of course, is where the chip from the motherboard goes, and most of the pins look like they make their way over to this pin, this part that goes into the motherboard. But for instance, this leg right here almost certainly looks like it, well, it like maybe is going over to the inverter. I think it's not quite clear to me. I think, again, it's just not really clear. So it'd be really helpful if someone who actually had this board could just tone out all of these connections, just sort of write down all the various pins on the sockets, the 2 sockets on the top or the 2 chips on the top, the pins on the bottom, and the wires that go off to the card, and just figure out what goes to what, because then I would easily be able to recreate this and then get that card working. And going back to the root directory here, so we have manuals, photos, we have ROM images. So there's the Sup'R'Terminal ROM. It's also a 2K ROM. And the manuals, we have a preliminary and we have the regular one. The regular manual is what we were reading. Let's look at the preliminary. Maybe for some reason this has schematics that they took out of the later one. It does not appear to have them. It has Computerland branding all over it. So this must have been sent to Computerland, maybe with like a pre-release card demo programs or source code and stuff like that. But yeah, no schematics. All right, so that's it for the Sup'R'Terminal. I'm not gonna be able to do any more with this until I get that little board reverse engineered so we can recreate it and then see if this card is working. So let's switch over to the Franklin 80 column card, the Videx clone, and see if this thing works properly. So like the other card, I'm just gonna stick this into slot 3. I'm not gonna connect up any of the wires here, but this one, unlike the other one, does not need these connections to work. I'll plug the video cable for the RetroTink into the card here, which of course is a little difficult because this cable is longer than probably the original one. There we go. And here we go, let's turn this on. Okay, it's working. PR number 3. No, it's not working. So, well, let's see if it's actually working. Okay, it's working. And you hear that that beep sound is lower pitched? If I hit Control Reset, it's back to the normal beep. And that is normal. The Videx Videoterm card, the beep sound is actually lower pitched to help you identify that it's running in 80 column mode. Clearly, the ROM on this card is a total copy of the Videoterm ROM, which is why it has the lower pitched beep as well. The Sup'R'Terminal beep while it was running in PR number 3 was normal pitched. It was the same as the Apple II. So this may not be displaying any 80 column text because I have a feeling is that that video Softswitch board was entirely replicated into the circuitry of this card. And that card relies on, I think, -12 or +12 volts and -5 volts or something like that. And that is picked up from this connector. So the video output of this board is probably working, but as soon as it tries to switch to 80 column mode, it doesn't actually work because the voltages are missing on this cable. Let's go find the manual for this and figure out which direction this goes on to the motherboard. Now, I briefly looked at this before starting this video, and it does look like they talk about Apple II compatibility. So here it's talking about how to connect it up to the Franklin Ace motherboard because it has that extra pin on there for that auto switching capability. And here it is talking about the auto switch capability. It says that's the text GR and it's a single pin on the motherboard. And if you are trying to use it on an older Ace 100 or an Apple II, you're gonna have to connect it right to the chip on the motherboard. And here it is, it's talking about connecting it up to F14 on pin 4. There it is, pin 4. And there is a picture of that connector on the motherboard. So I'm gonna connect it in the same exact way. And I've gone handheld with my Pixel, and there it is. You can see it connected up to the motherboard, and I have it in the same exact orientation with the little, like, I don't know, the holes you want to call it, where you can see the little metal contacts inside facing the keyboard. So let's give this another try. Turn it on. Oh, look at that. It's actually displaying something. And that's with, of course, without this wire here connected, the yellow wire, but that makes sense actually, but it's very jittery. Well, let's just see if we go to PR number 3, if it actually is in 80 column mode. And there it is, 80 column mode. And 80 column mode, it's kind of hard to read. Let me go to full screen so I can see it a little more clearly. Oh, wow, that doesn't look good at all. I gotta switch the mode of the RetroTink though. Let's switch this into a monochrome mode. So if we go and we switch this to component, it's gonna switch to a high res mode. There it is. That looks pretty good. It's a little jittery, but I have a feeling on an actual composite monitor, it probably looks fine. I think that this newer RetroTink doesn't do as good a job as the older ones at this high resolution text like this. Either way, this font looks kind of interesting. Now if I hit Control A, what happened here? Let's turn the computer off and on. Did something come loose? Or maybe we lost something on here. Okay, Apple II, that looks fine. Either way, we go to PR number 3, and we lost PR number 3. It stopped working. Obviously the card is still working, but no video display. Oh no. That is funny, but Control Reset takes this back as it should, but the card has failed. Is this a RetroTink problem, everyone? Do you think it is? Or is this a problem with the card itself? I should grab a composite monitor because I just don't trust the RetroTink for you know, doing a good job with this stuff. But I have a feeling something did die on this board. We kind of saw it happen right in front of our eyes. Okay, so the 2C monitor's connected. It's gonna be blanking a little bit in the camera, and sorry, that's just the way that my camera's working. I don't have a way to fix it to 60 frames per second or a 1/60th of a second refresh. So there it is, 40 column text mode, looks absolutely perfect. Let's switch to 80 columns. And just like I thought, this goes completely black, so it is not working. So yeah, something absolutely has died on this card. Could be that with this wire not connected, just floating here, that it's going to misbehave. So pin 4 of F14 is connected with a little clip and it goes into the yellow wire. Let's turn this on and we have a good video signal. And just like before, we have nothing now displayed. But there is a test to make sure that wire we connected is actually working. If I type in GR for low-res graphics, it should go back to 40 column mode. And it did just that. Now I know you don't see any text down at the bottom of the screen, and that's because the text mode is still over on the 80 column screen. It's not doing that mixed mode anymore. Mixed mode is not possible with 80 column mode. You either have to do full screen graphics or full screen 40 column text or full screen 80 column text. Of course, you can still do mixed 40 column text and 40 column graphics, but just not 80 column text with any of the graphics modes. Now I have a little bit of a hunch that one of these transistors on this board has failed. So I have the oscilloscope running. Let's probe around these transistors here. So obviously that's a video signal right now. I think that's the 40 column video signal because right now 40 columns is filled with that the @ symbols after I left graphics mode. And then we have this transistor, which doesn't seem to be doing anything. And this transistor here is showing nothing as well on any of the 3 pins. So maybe this is not a problem with the transistors at all, and there's something further downstream. Because I figured we're gonna see the 40 column on one of the transistors, and we're gonna see the 80 columns, which is initialized right now. I did PR number 3, the card. We should see 80 column text on one of these other ones, and we're not. And right now I exited out to 40 column mode, and I am seeing the 40 columns on the middle transistor there, this one right here. So if I go PR number 3, hit enter, there we go, the signal disappeared. So the transistor that's closest to me is probably handling the 80 column text. Let's turn the computer off and on. Let's see what we see on here. So we're not seeing anything. And if we do PR number 3 and hit enter, changes a little bit, but barely. Does lead me to believe that's probably a problem upstream. So I'm just gonna pull this card out of the computer here. There's a lot of corrosion on the legs on these top ICs here. I'm gonna just reseat those with some Deoxit. Let's see if that helps at all. Okay, Deoxit in these chips, these ones, and I kind of pushed on all the rest of the ICs as well, just to kind of reseat everything on the board. Let's just make sure these wires are still connected. Yes, they are. Oh, I didn't plug the video cable in. It's not gonna work without that. Let's plug that in. Okay, here we go. Got a video signal on the monitor. Let's see if this works. No, it's still not working. All right, and what I also have is one of these. This is an Apple II online store, warranty void if removed, slot riser thing. So we could plug this into here, and then that into the motherboard, and that should allow us to more easily work on the card. So it's floating above now. And let's just see if that works. The computer boots normally, and we're still getting the low-pitched beep in PR number 3, so that means the card is working raised out like this. Let me go look at the schematics for the Videx Videoterm, and hopefully we can make some heads or tails of that board and try to find out how this board works, because I think it's gonna be quite similar. Okay, so this is the schematics for the Videx. So, and right here you can see the outputs, D0 through 7, and it goes over here to this 74166, which is I think it's a shift register. And this is what converts the parallel data from the character ROM out to a single stream of data, which is actually what gets displayed. And I think it's pin 13, which is the output, goes into this gate, 74LS86, which goes through a 00, goes through another 86, and a transistor, which ends up right here on the output. And you notice here these gates here, this is the video signal, and it goes out, but then there's also H-sync and V-sync coming out of the CRTC controller, and that gets combined right here through a resistor and into that transistor. So right off the bat, when you turn on 80 columns mode, if everything is working, we should be seeing the H-sync and the V-sync in the video signal. So even if the shift register or the character ROM weren't working, but the rest of the card were, we should see the sync signals. And I wasn't seeing the sync signals on the oscilloscope. I don't know exactly which transistor is the 80 column one, but I think it's the one that's closest to me on this card here. And we should be seeing the H-sync and the V-sync in that video signal going to the base of that transistor, and I was seeing nothing. So I have a feeling that maybe the CRTC controller is the problem, or something upstream from that, because if it's not generating the H-sync, V-sync, and all these other signals here that control like the data lines that go to the character generator and stuff like that, then we're clearly not going to get any kind of video signal whatsoever. So on the schematics, it was pin 39 and 40 on the CRTC here, the CRT controller that were outputting the sync signals. And I've traced it on this board to go over to this 74LS02 over here, which matches the Videx schematics as well. That's the gate that's combining those together. So I'm going to plug this back into the riser here, and we're going to use the oscilloscope, and we're going to try to see if we see the sync signals coming directly out of the CRTC while the board is powered up. I'll turn this on, PR number 3, oops, PR number 3. Okay, it's already running. All right, so that is pin 40 on the CRTC, and that is pin 40 on the CRTC, and they both look exactly the same, which is not correct. And if I zoom in here, we're just seeing a whole lot of static on there. All right, well, either way, what I'm gonna do is I'm gonna swap out the CRTC, and let's see if that makes a difference. Here's a 46505. I think this is compatible. The one that was in here was a 6545. Let me double check that this is a compatible part. I'm pretty sure the Hitachi part is compatible with the 6845, which I think is generally compatible with the 6545. There's a couple things on 6545 and the 6845 that are different, but usually nothing uses that difference. And I think it's pin compatible as well. So let's give the Hitachi chip, which is one that I happen to have sitting here, whoops, a try. I just dropped it. Computer powers up. Let's see. We got, oh, it's freaking working. Okay, let me switch inputs. I was about to hook the oscilloscope up to take a look at the sync outputs. And we have 80 column text on the monitor. The only thing that's weird is the cursor is offset, which I think is obviously a difference between the 6545 and the 6845, which this CRTC is compatible with. And here we are in the machine language monitor, and yeah, it's working perfectly. I hooked it back up to the RetroTink, and you can see it is working, but you can see what I'm talking about with the cursor being offset. And yeah, like I said, side effect of the wrong CRTC. That's fascinating. The other thing you may be noticing is that the text is off the top of the screen, and that's because this is sort of a problem with the way the Videx Videoterm card works. The stock character is, I think, 7:9, and actually, to allow for the descenders on lowercase characters to not be squished up against the characters on the next line, they expanded the entire text mode to take up more lines than normal 80 column or 40 column mode on the Apple II. And watch when I exit out of this, you can see here, a good example of this, if I go to text mode, you see the top and bottom there of the 40 column mode. If we go to PR number 3, notice how much higher and lower the 80 column text is. And that means on a regular monitor like this Apple IIc monitor I have here, the way it's normally adjusted for Apple II text, it actually goes off the top and bottom when you switch to 80 column text. Now, before I get to that though, I want to talk about the CRTC controller. So here's the Sup'R'Term, and it uses that same Hitachi 46505 or whatever, the one I just put on this board that's not working well. It's working except for the cursor being bad. So I can't take it from this board. I have to go into my parts stash, see if I have a 6545. They're kind of old and they're kind of rare. The only thing is with the one I just took off here, it's in really good shape. I don't see corrosion on any of the pins, but let's put it back in. Maybe it was just a bad connection on the socket, and I did put Deoxit on the socket before I put this Hitachi one in here. So let's pop that out, and let's put the original one back in, make sure I have the direction correct. Okay, there it is, PR number 3, and it's not working. So that chip is dead. How fascinating that we literally watched it fail right in front of our eyes while I had the video capture running. I'm kind of amazed at that, to be honest. Anyhow, to get this working, I'm going to need to find a 6845. So we know what this means, though, that this 6545 is dead, died right in front of our very own eyes. All right, I went into my inventory parts and I found another 6541, and let's see about compared to the bad one. The only difference between these two, they're the same brand and everything. The one that died is a little bit newer, and it's an A variant. And the one I just found, which is untested, by the way, is not an A variant. So let's test it out. First, I gotta fix some of the pins. I found I have lots of 6845s and the Hitachi variant that we just tried that has the cursor problem. So those are very common, but these less so. PR number 3. And we have working cursor, call -151. And notice the cursor, how deep it is, like how much it goes below. And that's that extra line in the ROM, the way it's initializing the CRTC, that's causing the screen to take up more space on the vertical stretch. And there it is. You see how like the bottom line is literally off the bottom of the display on the RetroTink. So it's working. Let's see if Control A, I guess I should bounce out of there and go back. PR number 3. Yeah, okay, it's definitely switching. I think it was escape, and how do we clear the screen? It was the @ symbol. There it is, that's that reset the screen. Now we hit Control A, and that should give us AA. No, I think Control A was supposed to give us lowercase. Oh, you know what I'm realizing? That was on the Videx Videoterm ROM on the Apple II, but this particular card is designed to work in a Franklin. And Franklins, of course, have built-in lowercase support. They have a keyboard that sends lowercase letters to the motherboard and a caps lock key and all that. So they probably took out of the ROM the fact that the Control A alters the uppercase lowercase. Okay, that doesn't seem to do anything here. I'm looking through the documentation trying to figure out how to test the inverse characters. It might be this right here, Control Z, and if you push then 2, select standard 7x9 character set, or 3 for the other ROM, and on the original Videx card, that if it's the inverse ROM, you get inverse text. So on this machine, if we hit Control Z and 3, there we go, we actually get, what's it doing? Why is it going up like that? What the heck was that all about? Is that a symptom of the Apple II? Let me try that if I exit out here. Oh yeah, okay, that just happens. I guess if you push multiple keys together, you're getting some control character or something from the keyboard encoder that actually pushes up the line feeds, or it does a reverse line feed somehow. So that's not a fault of the card. So how do we clear the screen? Escape, Shift P, there we go. And we hit Control Z3, and there's inverted text. So that was my hypothesis, that the ROM on this particular Franklin Ace card actually contains both the normal and the inverse character set into one ROM. And using the same commands to get inverse text, or at least select the second character ROM on the original Videx card, gives you inverted text. So I'm recording a little extra segment here. So it turns out there are actually schematics online for the Franklin Ace video card. And I found this after I'd done all the troubleshooting on the card. But let's just talk quickly about how this works. One of the things I was able to confirm for sure is that the character ROM does not contain 2 sets of the font, one inverted and one regular, like the Videx card does. It actually uses the extra bit here, bit 7, which is the 8th bit on this 8-bit processor, to control whether the text is inverted or not. The character ROM outputs the bits to this shift register, which sends them serialized into this gate, and the LS74 sends that inversion signal into the gate and allows it to invert the shifted output, which goes through a few more gates. And if we follow up here, this makes its way into the auto switching module. And I wanted to point out, there's the input, that's the text GR that comes from the motherboard, or pin 4 on F14. Is this circuitry right here, which takes some signals from elsewhere on the card. These are the inputs right here. And that is what initializes the video output, or turns on the 80 column output when it is called for. And also the reset signal here turns off the 80 column output as well. Overall, the circuitry is similar to the way the Videx card is, but it actually seems like it's completely redesigned. Mostly they're using the exact same programming commands, the escape codes, the API for talking to the card. That is all the same to maintain compatibility with any software made for the Videx. But from a circuitry design, they seem to change it up a little bit, probably so they wouldn't get sued directly by Videx. The end result is it seems to use more logic chips than the Videx card, but of course it has that inversion feature built in and the Softswitch feature as well. Now going back to what I was talking about, how the 80 column mode takes up more lines of text on your monitor, which means that often on your composite monitor, the text is going to go off the top and bottom if you don't make any adjustments to your monitor every time you switch between 40 columns and 80 columns. The reason for that is because, like I said, it's adding extra scan lines between each row of text. That way the G descender and Y descender and anything that goes below the line is not scrunched up to the letter that's right below it in the character buffer. Now that is all controlled right here. These are all the registers on the CRT controller that's on these boards. Now this is the same on the 6845 or even the Commodore PET and any of those other systems that use this chip. These are all initialized by the ROM when you first initialize the card. And it's these vertical settings right here that add that extra scan line. And it also allows you to slightly adjust the sync rate and other parameters of the video signal that's coming out of these boards. There are two profiles provided here in the manual for the Videx Videoterm, one where there are 9 scan lines per character and another that has 12. I think the 12 is used for some of the alternate fonts that have more complex characteristics to them, but the default is the 9-line mode. But with that 9-line mode, that's where essentially it takes up too much space on the monitor, which causes the text to go off the top and bottom. We want to alter these settings so that the display mode is matching what's coming out of the Apple II. Now, for Videx cards, all you need to do is copy the ROM into a hex editor and you look for this string of hex values. There will be a table in the ROM that the routine just loads into the registers of the CRT controller at initialization. Now notice one of the ROMs is out of this card because I have gone ahead and I dumped those with my EEPROM programmer here. They are 2716s, and I found that the Mini Pro, which is this reader right here, actually struggled and couldn't read these chips, which is a bit odd to me, but my GQ 4x4 had no trouble reading these. So I'm not sure what was going on there because 2716s should be supported by the Mini Pro, but for whatever reason, it wasn't working. Now I went ahead and loaded the main program ROM, which on this card is this ROM here that has an A printed on it. I loaded this into a hex editor and I started looking around for the initialization values for the CRT controller. Now what I found is the initialization routines, or the values that are loaded into the CRT controller, slightly vary from one card to another. So you have to do a little bit of looking around to find the initialization table. You can't just look for these exact values because this card probably uses slightly different values than the Videx Videoterm card does. And I'm pretty sure that I found it. Here's 7A, which is one off from 7B. Then we have 50. Then we have 5D instead of 62. We have 1A instead of 29, 19 instead of 1B, 02 instead of 08, and so on. I'm pretty sure that these are the values because it ends right here with a bunch of 00s, which matches exactly these last 4 registers, which are always going to be 00. On this screen clipping here, I have the values that I've used on a Videx clone card that perfectly fit the image right into the correct spot of how I want it. So what I'm going to end up doing is I'm just going to type these values into my hex editor here and make a new EEPROM, and let's see if this indeed is the correct part of ROM that I'm altering and if it has the desired effect of correcting the position and the size of the image so it fits on the monitor. And we'll load up the fixed ROM into the EEPROM programmer. Yeah, this is all fine. And our new values here, 7B, 50, blah, 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 blah. There they are right there. I guess I could have edited them right here in the EEPROM software as well. And we're gonna hit write. There it goes. It's programming it right now. Let's hope that this works. This programmer, I don't generally use it. I seem to use the Mini Pro more often. This seems to have a little bit better support for older ICs. There we go, it does a verify, so it writes twice to it just to make sure that all the bits have written, and yeah, okay, I think we're good. Let's pop this into the card. There's one thing I just realized. Remember when we booted up this card using a 6845 or the Hitachi variant, how the cursor was weird? It's possible that these settings right here are actually gonna make it not work correctly with this chip, and I can go back to the Hitachi chip. And that's because the Videx card uses that Hitachi chip, or a 6845, unlike the 6545 that came on this card. Alrighty, here we go. Okay, powers up normally, which is as expected. PR number 3. Aha, look at that. So I definitely changed the values, and obviously when I type, it's typing, but it's completely out of sync. Let's swap over to the 6845 chip, or that Hitachi chip, and let's see if that makes it work. All right, chip is swapped over. Let's turn this on, PR number 3. Okay, so I'll take a look at that. It is actually fully synchronized. Okay, let's fill up the screen in 40 column mode with a little program there. And if we do PR number 3 and we run, all right, well, it's filled up, but the problem is it's, well, the cursor is still having that issue where it's shifted over. So that must be configured somewhere else in a different register. But notice it's better. It's definitely better, but see, it's still a little shifted over. I'm also noticing another issue is, notice how there's like an extra letter to the left of the square bracket. Not only is the cursor not working as well. So I think what I'm gonna have to do is figure out those calculations for the parameters that were on this card based on the data sheet for the 6545, because clearly it's slightly different. Also, it's funny with this chip in here, the top is kind of rolling as well. I think that might be because it's too close to the top. If we actually shifted it down and over, it would be fine. Yes, yes. Oh, weird how it like moved actually after I switched. Okay, so at this point, there's two choices here. I could try to fix these settings and keep the 6845 in here. I was talking to my friend Frank IZ8DWF about this problem, and he indicated there's actually one small difference between the 6545 and the 6845 that accounts for this shift we're seeing. There's actually a skew setting in the registers that only the 6545 supports, and it seems the designers of this board rely on that feature to make sure that everything looks lined up. Since the 6845 or the Hitachi chip I'm trying doesn't support that feature, it's actually the design of this board that's causing this. So there's no way to fix this in software. Or go back to 6545, take the original values that were in the ROM on this card and alter those so that it fixes the geometry problems and reduces the number of scan lines. You'll notice now between the capital letters on this test pattern here, well, I printed those messages, that there's only a single scan line now. So we're at a 9:8 font mode. We were originally at a 9:9, which added all those extra scan lines. I guess it added 24 extra scan lines, and that is what pushed the text up and down and out of the visible area on a monitor that's adjusted for a 40 column Apple II. I don't remember this being a problem back in the day when I had 80 columns on my Apple II Plus, but I must have adjusted the monitor so that it looked good at 80 columns, and when you were in 40 columns, it just looked a little bit squished. There will still almost certainly be a problem with lowercase descenders using this mode on this card right now, so we may need to alter the font as well, but I do have a way to fix that if we need to do that. Okay, I just wrote a little program here that just prints out some of the characters so we can actually see the lowercase characters, because on the Apple II Plus, I can't type the lowercase characters. And notice one of the side effects of me shrinking the number of scan lines with the original font that's in here, if you take a look at any of the things that have descenders, so the comma, the semicolon, but then especially the G and the Y, it's actually cutting off part of the character. The original font actually has more pixels that are going down below, but those are not being drawn because of the configuration parameters that I gave the CRT controller. We can fix this by altering the font though, and this is exactly what Apple did on the IIe and the IIc. They changed the font because they wanted the 80 column screen to also fit within the same boundaries as the 40 column screen. So yeah, they shrunk the font. So we're gonna have to alter the font to make it fit in the same way as this. But let me fix one problem at a time. Let me first try to figure out how to get this image looking correct on here and matching the 40 column output perfectly. And I'm back, and I got the settings all figured out. I ended up having to switch back to the 6545. I could not get it working properly with the 6845. No matter what I did, cursor was in the wrong spot, and it looked like the video memory is somehow offset by one character from what that particular chip expects. So the 6545 was the chip I had to use. It was actually a little bit of an interesting experiment, to be honest, because I always thought that they were pretty much compatible with each other. You could just like put one in place of the other, but clearly not. I'm assuming on something like the Commodore PET, if I tried to use a 6845, a similar issue would happen. Anyhow, as you can see on screen, that is the 80 column screen buffer and looks pretty good. If I escape out and go to 40 column, there it is. It also looks pretty good. You can kind of ignore that it looked a little, I don't know, washed out, so to speak, with the background. That is a RetroTink artifact hooked up to the monitor, the actual CRT. It looks absolutely perfect. But if we go back to PR number 3, there it is. Notice it's pretty much, the geometry is roughly the same. It's not perfect because, of course, the CRT controller is a bit different with the timing than the Apple II, but it's pretty close, and with the monitor hooked up, it looks good as well. It's not going off the top and the bottom. Now, what I ended up doing is using the data sheet here for the 6545 to figure out what all the parameters meant, because it's basically the same table here, the same control table as the one I was showing from the Videx manual for the 6845, but it's slightly different. I think this parameter here, R3, might be a bit different, but I didn't even end up having to change that one anyways. And of course, I used the original dump of the ROM, which is right here, to look at what the original values were for this card, the ones that it was using right out of the box, and then I started adjusting from there. I created a little table here. These are the original values on the left, all 16 of them, and these are the ones I ended up changing. Now, fortunately, one minor problem is I couldn't get the vertical frequency exactly right. You know, 59.97 hertz is what it should be, but it can only get it around, I think it's 59.6 or 59.7 hertz. Luckily, on the RetroTink, it's working, but I actually went and tried it with the old RetroTink and it doesn't work. What happens when you switch to 80 columns is the picture rolls. That might be a problem with some LCD TVs and things as well. With the CRT, it's absolutely not a problem. It's very forgiving with the vertical input frequency. Pretty much anything from like 50 hertz generally, or 51 hertz, all the way up to maybe 62, 63 hertz works absolutely perfectly, at least on the little Apple II monitor that I was testing with. Now, one of the things that determines the exact frequencies that come out of the CRT controller is, of course, the clock signal that goes into it, which is generated on this board with the crystal oscillator, so that's not something we can easily change. This does bring us back to the problem with the descenders on some of the characters. They're actually cut off when we're set to this 7 scan line mode. Now, what I went ahead and did is I actually dumped the EEPROM that holds the character ROM from this card so I could edit it and make a new one that does not have that problem. I have this program on my computer, which is a font editor. It's an 8x8 font editor. It's designed really to be used with the Commodore 64, but it seems like it has no problem editing fonts that, well, I've taken off other video cards. Now, the file I have loaded here is actually the stock ROM that is for this card. And here's like the J character, for instance, the lowercase j, which has the descender that we're talking about. Notice this is cut off here because this only shows 0 through 7, which incidentally is exactly the size of the font character cell I'm using now. I set it for 7, which actually means 0 to 7, so it's actually 8 lines. But see the little bit of the J that's missing there? It's actually here in the next cell. So this font ROM actually has a total of 16 lines for each of the fonts, and that allows you to have much more complicated characters if you're okay sacrificing some of the characters on your display. If you only want to have, say, 12, but you want to have double high text, you can do that, and you can have complicated characters based on these 2 cells. So any of the characters that have descenders, like here's G, and notice it's cut off as well, and that extra little bit is right there, is available and viewable on this particular editor. So all I had to do to fix this font is draw the G again where it all fits onto this cell and take away this extra little line that's on the second cell here. So I went ahead and did that. I moved everything up a little bit, anything that was using that extra line. So there's G, here's P, there's Q, same problem with those. And there's Y. Even though it looks a little strange, this doesn't use exactly the same font that the Apple IIe and the IIc uses for their lowercase and both 80 columns and 40 columns. But this is exactly how the font was. I just took 1 pixel away from this part that goes down. So let's turn this off and swap in with the font ROM. I haven't actually tested that in the card yet. So there is the program ROM that I have changed out. And let's get this font ROM out of here. And there it is. There's the new character ROM in the card. It's an NEC ROM. Hopefully it's fast enough or works or whatever. So we'll start by loading my little character program that's just going to print all the characters, including the lowercase ones. And as you can see here, with the stock character ROM in 40 columns, there is no lowercase. So if we do PR number 3, okay, good, it's working. And let's see if this is good. It's funny how a lot of the sharpness on the RetroTink has gone away. I think there's a couple different modes, like it locks on to the different frequencies, and it must have locked onto the 40 column and not onto the 80 column here. I'm gonna try turning it off and on. Hopefully it will re-lock on to the 80 column picture and give us that exact sharpness so we can see all those pixels. Well, I don't know if it's locked on because it almost looks a little bit blown out, but looks like it is working. So you can see the lowercase g if you look in that sea of characters, and the bottom descender is now visible. So that was a complete success. But just like before, if I exit out, there is the 40 column mode, and the geometry and everything looks very similar, which is really the whole point. There's no problem with the text going off the top and the bottom anymore. Now there is one other thing that I did, and it's a different font. I just swapped out the font ROM with the other font that I made. Now, unfortunately, I can't have two. Well, you could probably if I used 2732 and then you took the extra address line and put a toggle switch. You could actually switch right there on the fly. If we switch to PR number 3, take a look at this. It is what I call the fat font, P-H-A-T, and essentially I took the font from the Commodore 64 or the VIC-20 or any of those with the double pixels, and I adapted it to work on the Apple II in the same character size cell that is available to these 80 column cards. So there it is. It looks a little different, doesn't it? But it maybe is easier to read depending on the monitor you're using. In fact, if you have kind of a lower resolution color monitor, this is going to be easier to read. It's one of the reasons why the Commodore 64 went to a double pixel wide font. All the risers and the up and downs, the uprights I think they're called in the font language, all of those on the PET and the Apple II are just 1 pixel wide, but on the Commodore 64, Commodore went to double pixels because color text renders better that way. But I kind of like how the 80 column text looks, even though it doesn't really match. If we jump back into 40 columns there, PR number 3, I don't know, I kind of like it. Now, if you have one of these Franklin Ace cards and you want to run my modified ROM and the modified fonts for it, I will upload that stuff to the GitHub page. You just need a way to make those 2716 EEPROMs, or you could use bigger EEPROMs with an adapter in the socket here, and that should work without a problem as well. If you have a Videx card, like the Videoterm, an actual real one, or one of the clones, I have a modified set of ROMs for that as well, including the fat font and an inverted one, because you actually need those 2 chips, plus the ROM chip on those Videx cards, and it has the same geometry fixes that I have for this card, of course with the appropriate parameters because it's using a 6845 versus a 6545. It's quite possible that this Sup'R'Terminal card will also need fixing for the geometry. I have no idea what the geometry actually looks like on this because, of course, I can't get this working. So once I'm able to get that little adapter board working on this, then I will probably go ahead and modify the ROM on this if it needs it to make the geometry and the font work within the same size as the Apple II. Now you might be saying, hey, I don't even have an 80 column card, and it seems like the ones on eBay, or maybe in my country, the ones on eBay are really, really expensive. Here in the US, seems like it's relatively easy to find these Videx clones, and I got this Sup'R'Terminal card, I think for like $35. But I know in other parts of the world, that is not the case if you have an Apple II. So I wanted to mention one of my viewers here, Bradley, who has recreated several Apple II cards in KiCad and uploaded them to his GitHub. And taking a look at his repos, here it is right here. He has an 80 column card, which he recreated from the schematics on the Videx. And yeah, this is a Videx clone card basically, but an open source one with Gerber files, so you can make your own. Now, unfortunately, one of the things I'm noticing here is Brad did not integrate the auto switching into the card. You still have to use that separate Softswitch module that plugs in the motherboard like we talked about earlier in the video. It would be a great improvement to this design to copy the Franklin Ace auto switcher that's built right into the card so you could eliminate the need for that extra board. So that is going to be it for this video. I only got to the 80 column cards, and I thought I was going to be able to get to these other cards, but I know this video is way too long. But hopefully I made a pretty comprehensive video on Apple II and II Plus 80 column cards, including this original Sup'R'Terminal card, which I never got working, and the Franklin Ace card, which is sort of a clone of the Videx, but not. I'll put a link to my repo where I'll upload the ROMs for the ACE card and the Videx card along with the modified fonts if you want to improve your Apple II 80 column output. If you have schematics for the little adapter board for the Sup'R'Terminal, or you have one and you can just tone it out and figure out which pins are which, definitely let me know. I can just build one up on a little PCB and then I can see what this board is all about. I'd really like to test the compatibility of it versus these Videx type cards, at least from a software compatibility standpoint. If you found this video interesting, I appreciate a thumbs up. If you didn't, you know what to do. Put your comments down below if you have any thoughts about all this sort of stuff. And I want to thank my patrons. Their names are scrolling up the side of the screen. They get early access to videos and other behind the scenes content. So if you want to become a patron, you can do so at the link in the description below. And I think that is going to be that. This video is already long enough and I've done a lot of talking. So stay healthy, stay safe, and I will see you next time. Bye.